Algebra 2. We're in 2.5 talking about inequalities today. We've been doing equations for a while. Equations are anytime you have an equal sign. Inequalities are similar. It's just instead of equal signs, you have either greater than or less than, or greater than or equal to, or less than or equal to, or even the most uncommonly used, not equal to. I don't think our homework does not equal to at all in these. I think it sticks to the other four. So the first thing they're going to ask you to do is graph these. And by graph, I don't mean grab a piece of graph paper. We'll do some graphing this year with graph paper. If you don't own any graph paper, you might want to buy one because that's coming around chapter 4 and we're halfway through chapter 2. But we're going to graph just a piece of the number line. So if we wanted to graph what piece of the number line has numbers that are more than 2, you might remember doing this from Algebra 1 experiences. If we're doing pieces of the number line where x, any number, the number we're thinking is more than 2, that would be not including 2, but everything that's to the right of 2 on the number line. We have two choices for what we do here for punctuation. If we want to include the 2, we do a thing like this and we fill it in. Here we don't want to include the 2 because we're looking to describe what numbers make this a true sentence. 2 itself is not more than 2. 2.0000001 is more than 2. 3, 4, 5, 6, 10, a billion. Those numbers are more than 2. We want all of them, but we don't want 2 itself. So if I draw this little circle and do not fill it in, that's a way of communicating 2 itself did not work. 2 itself is not more than 2. So we're going to do a little open dot, and then we're going to draw an arrow headed to the right describing the portion of the number line, everything that's above 2, starting at 2.00001 kind of stuff, all the way up to 3, 4, 5, 6, 7 till the world ended. If we're going to go x less than 3, we again want to use this symbol with the 3, meaning 3 itself does not make this a true story. 3 itself is not less than 3. The stuff that is less than 3 is like 2.9999999 and on down to the left. So greater thans, we're heading right. Less thans, we're going to head left. If I say that my number can be greater or equal to 5, I just changed the game a smidge. Okay, now 5 is a winner because we can either be greater than 5, 5.00001, 6, 7, 8, 9, 10, a billion, or you can also equal 5. There's a double meaning of this sign. We can either be bigger or equal. So now 5 is good news. So instead of leaving this as an open dot, we're going to fill that in. Okay? This is called being exclusive. We're excluding the number when there's a greater or less. This is called an inclusive symbol because it includes the 5 borderline number itself. And as always, the greater numbers live to the right. So we start at 5, include the 5, head right. For this one, we go 7 is our boundary number. I'm going to fill in because we can either be less than 7, 6.99999, 6, 5, 4, 3, 2, negatives, anything like that. Or you can equal 7. Anytime there's an equal sign involved, we're going to do the inclusive symbol. And anything less is involved, we'll head left. You might want to pause the video, try the next like 4 or so, and just see if you're okay with them. There is a difference on the next 4. Instead of sliding the variable on the left, I slid the variable to the right. So you can either pause it and try, or you can just continue to listen in if that difference has you bothered. For this, I'm going 3. I'm not filling in because there's no equal sign, so this is exclusive. Then we have to realize everything's done from the variable's point of view. From the variable's point of view, the variable is more than 3. Since the number is more than 3, we need to head to the right. The numbers that are making this a true sentence would be filling in here 4, 5, 6, 7, 8, 9, a million, right? So we need to go to the right to capture all of those numbers. Even though it's a less than symbol, we're headed to the right because I backward sized the problem here. We have to do everything from the variable's mindset. So here, from the variable's point of view, it is smaller than 2. 2 is the larger number. Back to elementary school, like the alligator or Pac-Man is eating the 2. 2 is bigger than the numbers we want. So 2, an open exclusive sort of dot because we did not have an equal sign. And since x is smaller than 2's, we want to head left. If the problem being backward makes you mad, just copy it the other way. Put the x first, put the 3 second, and make sure that the alligator is eating the variable. Now this question is like the ones we did. If this bothered you, just put the x first and the 2 second, but when you switch them, make sure the alligator was eating the 2 before. It still is when the question is like the other one. This we're going to fill in with the 5. It's inclusive because the equals, we want to include the 5. And then from the variable's point of view, the variable is more than 5. 6, 7, 8, 9, 10. Those kind of numbers would make this a true sentence. So head right. This one we'll fill in again because of the 4 has an equals, so it's inclusive. And then the variable is less than 4. 4 is the larger number. To make a true sentence here, 4 itself can work, and so does anything smaller than 4. 3, 2, 1, that kind of stuff is to the left. And then we'll cross the line here in a minute and do some different stuff. But if they just give you the problem with the x already alone, what they're going to want to have happen in the homework is just to make a graph. And they don't mean a graph on graph paper, they mean a number line graph like I just did. Open circles when there's not an equal sign, fill that in when there is an equal sign, go greater than to the right anytime the variable is bigger, go left anytime the variable is smaller. Second thing we'll do is they'll give you some more problems where the variable is not alone. So your job will be to solve, do some opposites, whatever you do to one side, do to the other, all that kind of stuff, to get the variable alone. When you solve these inequalities, the greaters and the lesses, there's one special scenario where something different happens. You don't have to worry about equations. You can scan your memory bank and see if you remember what that is. We'll talk about that when it crops up. If you want to skim through the rest of these problems, there's 1, 2, 3, 4, 5, at least 5 where this is going to happen, that we're going to have an extra thing we're going to have to adjust to greater than less than problems that you don't have to worry about when it's equals. I don't care about show and work on these, but we're doing the same kind of stuff we've been doing all chapter long. If you see an add 3, you've got to subtract 3. If we subtract 3, this wipes that out. The variable is left. We subtract our 3. The sign just stays the way it was. Subtract 3. We're going to get 3. In some of the homework, I'm just going to ask you to solve it, and you get that answer. That's all I'm after. There's other questions where the directions are going to ask you to write something called set notation. Set notation, you break out these squiggly brackets or set brackets, and some of you from geometry have seen those more than people that haven't had geometry. But when we ask for set notation, they're going to go squiggly brackets. Whatever the variable is, they'll put the variable up front, draw a vertical bar. It's not absolute value bars, it's just a single bar. And then you get the answer at the back end. I'm not real big on this, okay, but I just do this in case you go to college, you go some other school, you go somewhere where they feel like doing set notation. Our book is in the mood to do set notation. We would read this as the set of all x such that, the bar you read as such that, x is greater than 3. I'm not a huge fan of that because it's more symbols and writing to basically describe the same thing, but it's a thing. So we're going to do a touch of that. So again, squiggle brackets, start with the letter we have, one single vertical bar, and then the same answer we were doing. And if we wanted to do set notation, we go an open circle, label a 3. It's a greater than problem, so we head to the right. There's 3 possible ways the answers could be asked of you, and we'll look at the homework before we sign out upon the video. But you can have a solution type answer, you can have a set answer, or we can have a graphing answer. It depends on what the directions say from group to group. Here we're looking to divide. Okay, we're doing opposites. And 3 wants to multiply, so we're going to divide. If we divide the 3 is gone. The variable's alone. The sign is still there. Make sure that equal signs, bring those with you. Sometimes people get careless on those. But if we're going to divide by 3 into 6 goes twice. And if they just want a solution answer, we're good. If they want a set answer, a squiggle bracket, It's an X again. If this were some other letter, I'd start with the other letter. 1 bar, and then the same answer that we just had. If we want to go graph, we fill the dot in with 2, because that was the number we got, and then less stuff. We go left. They could want 1, 2, or all 3 of those answers, and again, we'll take a peek at the homework in a bit. For this one, we want to divide by -4. If we divide by -4, the x would be alone. If we divide by -4, positive dividing negative, and those are different, goes negative. 20 divided by 4 is 5. And then if we were in the room, I'd go like this and just act like I was fine and walk away and see if anybody would give a yell, because that is not right. So here's a situation I alluded to a minute ago that we have about 5 of these. Anytime you multiply or divide by a negative, if the negative is with the variable, and we're multiplying or dividing by a negative to get the variable alone, you have to turn the less into a greater or vice versa. But the sign would turn back the other way. I'll do one more set notation. The notes page, I did the set notation all the way down, but I'm just not feeling that right now. But for set notation, we go squiggle brackets, whatever the variable was in the problem, single bar, and copy the problem in there. For the graphing, we would go open circle anytime that we lack an equals, label what number we had, which is -5, and then greater stuff, we go right. And again, some of the homework will want 1 or 2 or 3 of those answers. We'll look at it in a second. So this, we're dividing by -5. To get the variable alone, we're dividing by -5. If we go negative dividing negative, that's positive. 20 divided by 5 is 4. And then the question becomes on these turn or no turn. And the answer here is turn. The greater needs to become a less because we divided by a negative. If a negative is with the variable, that's what's going to make us get the turn of graters and the lesses. And don't forget to bring the equal sign along for the ride on those. This we're going to divide by 3. To get the x alone, we'll divide by 3. If you divide with different types of signs, that's negative, as always. 18 dividing 3 is 6. And then the question becomes turn or no turn. Some people on this will yell turn because the negative was involved. Sorry, no turn. You only do the turn of the sign when the negative's with the variable. A negative multiplying or dividing with the variable makes us work with a negative in our opposites. That makes us turn. So this, we would look to get the variable alone, divide by -4. Negative dividing negative is positive. 7 dividing 4, I'm just going to go fraction. And then the main question becomes turn or no turn. This is going to be a turn. The negative was with the variable. We had to divide by a negative. When we're working with those negatives with the variables, we turn them for multiply and divide. Add and subtract, that's not even a feature. Add or subtract, not even a consideration. Multiply and divide is when we turn, when the negatives are with the variables. So if we get this variable alone, there's a negative with the variable, so that's going to be a turn. We're going to need to divide by 4. So a positive fraction dividing a negative thing will be a negative answer. For 4/5 to divide 4, maybe take a trip to the side. 4/5 divides 4. 4 is like it's over 1. Dividing fractions makes us flip. If this gets flipped, the 4's are going to cancel once it's flipped. This is going to settle in to be a 1/5. Sneaking ahead to our last column, we want the variable alone. We're going to have to turn. There's a negative multiplying with the variable. We're going to have to do some dividing, negatives with variables. That's going to turn the less into a greater. Make sure you bring the equals along. If we're going to divide by a fraction, we'll have to flip the fraction. But first, let's think negative with negatives on multiply or divide is going to be a positive result. And we're going to want to go dividing by a third is going to flip the third, have a 3/1. And that's like it's over 1 already. A couple of 3/1s, that's going to make a 9. Final one of the day. We have a variable on each side here, so that's a little different than everything we had done previously. If we want to get rid of this, we can subtract a 4x. Subtracting a 4x gets rid of positive stuff. Or over here, we could subtract 6x. That would get rid of this. If I had a negative on these, which I don't, but if I had a negative, I'd add to make a negative go away. It doesn't mathematically matter to be correct whether you subtract the 4 or subtract the 6, but I would subtract the 4 because if I go and subtract 4, 6 minus 4 stays positive. Whereas if I would have gone the other direction and subtract 6, 4 minus 6 would go negative, negative starts to involve the terms, it just makes more work. So I'd get rid of the lower one, subtract 4x, so that's out. Negative 4 is still there, less than is still there, the minus 2 is still there. The only change I made is to subtract the 4x to get one of those variables gone. I got a 2x there. And again, adding or subtracting never turns the sign. It's multiply and divide that might turn the sign. So looking for the variable again, as always when we solve, we save multiply divide for last. So we'd want to add 2 to get rid of the 2's. Add 2 to this. Negative 4 adding 2 is negative 2. And we leave the sign alone. When we're adding and subtracting, we don't even think about changing the sign. The 2x is still there. To get the variable completely alone, now we're going to look to divide by 2. Dividing might make us turn a sign in some settings, but only if the negative's with the variable. This negative over here is harmless. I'm not going to turn the sign. Positive 2 is multiplying. I'm dividing by positive 2. Negative dividing positive is negative. When 2's divide, that's 1. And I'm going to go with this. Some people get a little OCD and they like their variable on the left. There's no problem with that. If you always like your variable on the left, no harm. If you want the x to switch from left to right, you'd have the negative 1 switch from left to right as well. But the sign has to turn if you do those switcheroos. So the alligator was eating the x. You want the alligator eating the x. One more set notation to go out on just to do it. So this would have 2 possible answers. I wouldn't care which one you did. For sure squiggle brackets. For sure x's. For sure a single bar. But if some people went with this and other people went with that, it doesn't matter to me. If we're doing one more graph, we go negative 1. Because we lacked any kind of equal sign, we do the exclusive, not filled in sort of dot. X is more than that, so we want to go to the right of that, and that would be a good graph answer. Pick one of these 2 to be your set answer, or pick one of those 2 to be your solution answer. Homework peak, we are on 77. And I made up my own directions, and the syllabus has my own directions on them, but I'll just tell you. The book directions wanted the solution set every time, and they wanted you to graph every time, and I just wasn't feeling that. Okay, so what we're going to do is from 1 to 12, we're going to do the solution sets and the graphs. Starting on 13, we're just going to do the solutions, and this is what I mean by that. So if we were working problem number 1, I'm going to want the solution set, the squiggle brackets thing, and I would want the graph answer, the open dot, filled in the dot, right, left thing. So from 1 to 12, we're going to obey their directions and do what they asked us to do up to 12. We'll do the set answer, the graph answer. So if this is number 2, I want the set answer, I want the graph answer. I don't even care about this, it doesn't matter to me. Set answer, graph answer, 1 to 12. When we get to 13, we shift gears, and I only care about the solution answer. No more squiggle brackets, no more dots, no more rights, lefts, arrows, number lines, none of that. So we're going to go complete opposite on the rest of those. So 1 to 12, the dots and arrows for the graph, 1 to 12, squiggle brackets for the sets, and that's it on those. And then from 13 to the end, forget all that. and just do the x greater than whatever, x less than whatever answers till the end. Email me if you have any questions. We can Zoom sometime if we need it. See you guys.